Okay, so let me start. Okay, so let me quickly go through this RLHF and then they will start the demo session. So this reinforcement learning with human feedback. Okay, so this is a very important component in large language models. Yeah, so what is the problem with the instruction fine tuning is that you know that till now what was happening is that you are simply training your model. Okay, so like you can give your data and then you are training your model, but your model is not getting any idea what human wants, like exactly what human wants or which output is preferred by a human. That understanding was lacking inside of LLM. Okay, so this human feedback, reinforcement learning with human feedback. So this RLHF concept is basically, that is the idea that now model will have the understanding what human wants, like this automatic metric, like I talked about the Ruse metric, Blue metric, or the Meteor. They are simply string to string matching. Like we are also working on a kind of semantic similarity metric. Like suppose if I will ask you that how are you, and I am expecting an answer that I am fine. Now if suppose you are not giving me the answer I am fine, simply you are saying awesome, but that is also okay. But if you will do calculate the Meteor score, you will get 0, because I am fine, you are not getting any matching. Awesome, there is no match, there is string matching is 0. So in the semantic level, we are not doing any matching, it's simply a string matching. So but user is also, but awesome is also very much equivalent to this. So this was basically, you know, the lacking inside the LLM. So instruction fine tuning takes an existing model and fine tunes it using example pairs of natural language instruction and the output. So you know that this is called the instruction fine tuning. This is what I told you, that you have a pre-trained model. Now you take the pre-trained model and you fine tuning for a new task, which we have done. I have shown you that we inserted a adapter and we simply used a small amount of data to train the adapter, and now the LLM has the understanding of the new task. So these examples help the model understand specifically how to behave when given instructions. As a result, the model is then able to evaluate unseen tasks in a similar way. Before instruction tuning, these models do not know how to behave with many types of natural language instructions and would fail to solve the task. So like you know that what basically you have to instruction fine tuning means that you have to you have to collect these many examples, like what is the boiling point of nitrogen, then answer the following question by reasoning step by step. Okay, and suppose these are the answers, like what is the boiling point of nitrogen, minus 320 degree Fahrenheit, answered by step. So these are the different tasks, instructions you can collect, and then you can simply, you know, that fine tune the LLM like by using the prompting or by using the adapter. So while instruction tuning is simple and straightforward, helps a model to generalize to several tasks, it has multiple limitations. One limitation is that it can be difficult and expensive to develop or collect a comprehensive set of rules for every possible combination of instructions. This means that some optimizations may be missed or not fully exploited. Additionally, the optimization process can be computationally expensive, as it involves exploring a large search space of possible instruction sequences. So it was you know, the difficult. You know that what we can, so what is this RLHF then? So in the RLHF there are, I will talk about the steps. So in the RLHF also, you have to, in the first step you have to collect some data. Okay, so you have to select some task which are, you know, obviously if the task is numeric in nature, like for example the boiling point of nitrogen, so there you cannot expect a different answer, no. Like when you will run multiple times the LLM, you can't expect different answers. So you can't select those kind of tasks. You have to select the task where you can expect different answer from LLM different times, like there is a generation task, or there is a summarization task, or there is a reasoning task, where if you run multiple times the LLM, you are expecting different answers. Okay, so this way you have to basically collect some demonstration data, like explain the moon landing to a 6-year-old. Okay, so explain the moon landing to a 6-year-old. So this is an explanation based answer. So the LLM has to generate the explanation how a moon lands to a 6-year-old. So now you give this instruction to a LLM, and you know that LLM is having parameter like temperature. You change the parameter temperature and you run multiple times. So LLM will give you multiple results. So now there is a human leveler. So this human leveler will read all the outputs, and then the human leveler will assign a score to each of the outputs. So which is the best, like it will rank all the outputs. Okay, like we used to give a ranking. Raghavendra, just close the door. So basically this human leveler will assign a rank to basically all the outputs. So now this ranking will be using as if this is a kind of reward model. Okay, so we will now train a neural network to automatically generate this kind of ranking. So this ranking data is a kind of level data. We will try to develop a neural network which can generate this kind of human ranking automatically. So given this human generated data, we will now train a neural network to which can automatically give this ranking given a text data. Okay, and now this ranking will be used as a reward function, and there will be a RL part which will be used to the fine tune the LLM. So this is the overall model. So I will now describe you one by one. So you have to collect the demonstration data from the users. So this demonstration data collection is very, very important. So as I mentioned, you cannot select the numeric examples, or you cannot select the where there is a straightforward answer, where there will be no difference in the answers. The labelers provide demonstrations of the desired behavior on the input prompt distribution. Then a pre-trained GPT-3 model is fine-tuned on the data using the supervised learning. So a labeler demonstrates the desired output behavior. This data is used to fine-tune GPT-3 with the supervised learning. Okay, so collect comparison data and train a reward model. So basically what we are doing, we are the same question, explain the moon landing with a 6-year-old. So we are giving this to either same LLM or multiple LLMs we are giving. We are generating different outputs. Now there is a human leveler. This is the human feedback, no? We are talking the RLHF human feedback. So there is a human leveler which is assigning the ranks. That D is better than C, C is better than A equal to B. So he is assigning the ranks, and this data is used to train a neural network. So the now neural network, it is taking the input, the text, this out text, and it will generate the human-like ranking. So based on this training data, it will behave like a human. So a data set of comparisons between model outputs is collected, where labelers indicate which output they prefer for a given input. Then a reward model is trained to predict human preferred output. So now, so basically now what is, suppose what is happening is that there is a policy, like the RL part has to be used. So optimize a policy against the reward model using the reinforcement learning. Suppose there is a new prompt, write a story about the frogs. So this is the policy. PPO means the policy optimization. So you know the this our model. This is the LLM. Suppose this is the LLM is generating output. Write a story on the about the frogs. So LLM is generating the output. So now this output is given to the reward model. So this is the reward model which here we have trained. So this reward model is trained on the human generated data. So human has given the ranks and we have trained the reward model based on this. So now you know that reward model calculates a reward for the output. So this is the reward, okay. So this reward is a feedback. So this reward is a feedback to the LLM. So LLM will be fine-tuned based on the reward. So some layers of the LLM will be fine-tuned. So the output of the RM is used as a scalar reward. The supervised policy is fine-tuned to optimize the reward using the PPO algorithm. Okay. So this is the thing. So yeah, so this RLHF, this is the step. These are the 3 steps only. So RLHF is very, very powerful in a sense that now there is a human feedback. So you know that sometimes human feedback is necessary, as I mentioned that what human wants. So this feedback now you are giving to the LLM. Initially you can train your system on a huge amount of data. But finally what human wants, what human likes, what human dislikes, that feedback you can only give through the RLHF. So it has many applications in game playing, in personalized recommendation systems, robotics human feedback, education AI based tutors. Okay, and you know this OpenAI has always shown that when you are incorporating the RLHFC, there is a huge improvement in the performance. So the performance of various training procedures for different model sizes. Model performance is measured by how often summaries from the modelers refer to the human written reference summaries. So you know that RLHF has only recently become well known, but it has a long history. In earlier days, it was often used in robotics. OpenAI only employed this method years ago and showed that human feedback models outperform supervised or the pre-trained models. So yeah, so this is the thing that, as I mentioned, that you have to collect some task. You used to use the different LLMs or maybe vary the temperature parameter of the LLM and run LLMs multiple times. Then you use the human judge to evaluate the LLMs. Now you know that these judgments, so basically you know there is a neural network. So this neural network, the reward model calculates the reward for each summary. The loss is calculated based on the rewards and the human level. So this reward should match the human level. Like if the human has mentioned that jth summary is better than the kth summary, then the jth reward should be higher than the kth reward. So this way the reward model will be trained. The loss is used to update the reward model. Train policy with PPO, a new post is sampled from the dataset. The policy pi generates a summary for the post. The reward model calculates the reward for the summary. The reward is used to update the policy. Yes.
And this reward model is value-based or policy-based?
So this reward model is a neural network, simply a feed-forward neural network.
Ma'am, so the type of RL we are using.
Oh, this one. This is the PPO, policy-based optimization. Yeah, so these are the 3 steps basically, as I mentioned. So you just have to remember these 3. And limitations. What are the limitations? So obviously limitations are that, so you have to always take the human feedback. No, you are taking the human feedback. So you understand that how much, so it's a huge manpower. So many samples you have to collect, and each sample will be evaluated by the human, a particular human expert. And what is the qualification of the human expert? And as in my previous class, I was mentioning about the biasness. If the human expert is biased, then what will happen? So suppose you have your own inherent biasness, then that will be reflected in your labeling. When you will label the essays, there will be a biasness, and that in turn will be a part of your reward model. So that will be again a part of your LLM. So you have to make sure that your human expert is having sufficient knowledge, sufficient educational background, he or she is bias free. So that is another issue. Okay. So there are many benefits. Obviously it is improving a lot, like you know that because of the nowadays whatever we are seeing the ChatGPT's performance, that is because of the RLHF only. Adaptability, a new it can be easily adapted to a new domain because of RLHF. Reduced biases. So though an iterative feedback process, RLHF helps identify and mitigate biases present in the initial training data. Continuous improvement. So there are several benefits, but as I mentioned, the challenges are that only that this you know that human like human feedback, that it's a huge cost. Identifying the demonstration data, which task you will consider, then deploying the human expert, taking feedback from them, that is a huge cost, and companies can only do this. But now researchers are working on how to automate this process. So there are some recent papers where researchers are trying to no need of having any human expert in the loop, you can also automate this process. So that they are doing. Okay, so this is all about the RLHF. Now so let me just quickly discuss another thing with you. Yeah, so let me just introduce one more thing to you. So nowadays people are also working on this multimodal information processing. Okay, so this is also a very important topic in nowadays research. So basically what is this why multimodal learning? Because you know that our experience of the world is multimodal. Whenever we are seeing an suppose there is an object and we have to take a decision about an object, so we are not only we are using our multiple sensors, no, we are seeing the object, we are touching the object, we are smelling the object. So we are using our multiple sensors, we are collecting information through multiple sensors, and then we are taking a decision. So that's why it is a multimodal system, that we are collecting information from multiple sensors and then we are taking a decision. So that if you see our social media also, so social media is full of multimodal information. Like when we are uploading something, we are not only writing the text, we are uploading the images or the videos, or our newspapers. Newspapers are the full of images and the text. So everywhere it is a multiple sources of information. So there is not only a single source of information, but there are multiple sources of information. So we should rely on multiple sources of information. Okay, and that's why in natural language processing also people are working on multimodal information processing. And there are many tasks where this multimodal information processing is very useful. Like for example, you have to identify the emotion of a particular person. So suppose two persons are talking. So what is the emotional state of a particular speaker? So if you simply see what the speaker is saying, maybe that is not sufficient. But if you can see the speaker's facial expressions, or the body language, or the tone, then you can better understand the emotional state of the speaker. So the audio, video, and also textual description all together can help you in understanding the emotional state better. So that's why multimodal information processing is very, very important in natural language processing. Similarly, you know that when we are working on the summarization, so we are collecting data from the Twitter. So you know Twitter data is full of multimodal information. In the Twitter mostly we are uploading the images and the text. So suppose we want to develop something for the disaster situation, because during the disasters physical connectivity is lost. People stay connected with each other through social media, no? In Facebook there are many suppose there is a earthquake, there is a alarm that whether you are safe or not. People used to write in the Facebook whether they are safe or what is the situation in their area. So can we collect all the tweets or all the Facebook posts related to a particular earthquake prone area, earthquake area, and then maybe we can classify these posts into two categories, informative and the non-informative. So and now informative post can be further summarized, and now this summary can be given to the rescue team, and the rescue team can plan for the rescue operation, that how many people are stuck inside a house, whether there is any water supply or not, electricity supply or not. So you know when you are classifying the tweet into informative and non-informative, this multimodal content is very necessary. So you know, and multimodality is very important in many tasks. Like I mentioned to you several tasks of dialogue systems, no? Like we are working on a virtual doctor. When the patient is not only showing telling the symptom in text, but also showing the sign of the symptom. Okay, like when we are developing the sales agent, that customer is not only mentioning the features in text, but sometimes some features he or she is also expressing in image, like rose gold color, he or she can express in image. So this way you know that multimodality is helpful in many different areas. And you know it has been shown that image and text are in general complementary to each other sometimes, because there are some concepts like love, affection, which can be better described using text. No, what is the love, what is affection, these are you can easily describe using text. But how a piano looks like or how a monkey looks like, if it's very difficult to describe using text, you can easily describe using image. So text and image are complementary to each other. So that is another reason that if you have multiple sources, you can extract, you know, complementary features. Yeah, so here in general you used to have multiple sources and then you extract some features from different sources, you fuse them together and then you pass through some layers, classification layers. And you know that you can either fuse the features at the, you know, that at the very beginning, like before taking the classification decision, you can extract the features, then you fuse the features, then there is only one classification layer. This is called the early fusion. Okay, so you are extracting the feature here, you are extracting feature from here, you are extracting feature here. This is the fusion. So feature fusion, and then you are passing through the model and the output. But this is a late fusion where individual modalities are processed separately. Okay, so basically in the output level there is a fusion. So it is the very kind of a voting based ensemble. Okay, so we are doing the ensembling but at the decision level. Okay, now there is an intermediate fusion. So first we are fusing sensor 1 and sensor 2. Then in a hierarchical way we are adding, like first we will be adding the text and the image, then that will be added with the audio. So like this, in a hierarchical fashion we are adding. Okay, so we are also working on the multimodal information processing for a like my research group's focus is on multimodal information processing only. Like we are working on dialogue systems, okay. So you know that I mentioned this to you. In a dialogue system there are many components. So one is this natural language understanding. The meaning is to understand the communicative intention of the speaker, whether the speaker is asking a question, or it is a statement, or it is a greeting, or it is an open question. What is the type of the utterance? That is called the dialogue act classification. So we identified this, but in a multimodal setting. So we not only consider what the speaker is saying, but also the speaker's facial expressions and also the audio tone. We consider this. And also, you know that we understood that there are some important tasks which are, you know, the some auxiliary tasks, like emotional state of the speaker has an influence on the dialogue act. Like if you are, suppose for example, if you are sad and you are saying, well, you know, I appreciate you coming over and talking to me, I mean it definitely helps, then this is a kind of acknowledgement, okay. And if I know that you are angry and you are saying that I can't leave it, you caused a hole in my dinghy floor, then this is an indication of a disagreement. So the emotional state of the speaker can help us in understanding the dialogue act better. Like suppose you are saying okay, okay sure. So now this okay sure could be agreement or disagreement. So how to understand this? So if you know the emotional state, like person is sad and saying okay sure, then this is an agreement. But if the person is angry and saying okay sure, then this is a disagreement. So this is the, you know, that this is the thing. So and we have shown that in the data set also there are many instances where when you are considering the multiple modalities, like here, fine, then you tell Roger about the because he was really looking forward to this. So here the text suggests agreement or the opinion, but the audio is suggesting commending tone, video is suggesting furious. So from this, though the text is suggesting a agreement, but after considering the audio and video, we understood that this is a kind of a disagreement only. So the dialogue act is basically command. Similarly, second, that's very amusing indeed. So here text is again showing agreement, audio is showing sarcastic tone, video is a slight anger. So we can understood that the correct dialogue act is disagreement. So then we proposed a deep learning based model. So here our main task is the dialogue act classification. So you can see here our main task is the dialogue act classification, but our auxiliary task is the emotion recognition. So it is a multitask model. So we are solving two tasks simultaneously, but the emotion recognition is our auxiliary task and the dialogue act classification is our primary task. So error will be calculated at the both end, but more focus is like given to the you know, the dialogue act classification. So now let me discuss about just one important task. Other task I think I have already mentioned to you, this virtual doctor, yeah, so this one. So we are also working on, you know, identifying the complaints. So like when you are purchasing some product from the e-commerce site like Amazon, Flipkart, so we are often writing the reviews in their site, and just imagine the Amazon or the Flipkart, they are regularly receiving so many reviews, and some of the reviews are positive, some are negative, some contents complain also. So these e-commerce companies are interested in complaint only, because if they can identify the complaint, they can accordingly modify their product or their service. So how can we identify whether a review contains complaint, and then if a review contains complaint, on which aspect? Like a product can have many aspects, no? Like a camera, a mobile phone has many aspects like camera quality, battery life, you know, the brand, screen size. There are many aspects of a particular product. So maybe the customer is not complaining on all the aspect, but on a particular aspect. So what is that particular aspect on which the customer is complaining? So this is called the aspect based complaint analysis. So here also you know that we developed a multimodal complaint data set. So through the Amazon site we collected data set. Our multimodal complaint data set is having this kind of images and also the text, okay, and we are annotating them with the emotion, sentiment and the complaint. So we are categorizing this, whether the person who has posted this complaint, what is the emotion level, what is the sentiment level and what is the complaint non-complaint level. Yeah, this is our data set which is also available in my site. You can download this data set. So there are 3962 reviews, 2641 reviews are non-complaint and 1321 reviews are complaint, and this is the distribution. Some samples of the data sets. There are different domains: book, edible, fashion. These are the different domains that we have collected. And then you know that again our complaint is our main task and emotion and the sentiment are our auxiliary task, okay, because we have shown that there is a correlation. When the person is complaining, mostly the person's sentiment is negative, emotion is anger or the disgust or the sad. Mostly when I am complaining, I must be very angry or sad or disgust, and also my sentiment will be negative. So if you can identify the sentiment and emotion correctly, you can also identify whether it is complaining or non-complaining. So that's why we are considering emotion and sentiment as the auxiliary task. Okay, and now here we also identified, like you know, we do not want to develop the models as a black box. Like you are giving the text and you are getting the output, whether it is complaint or non-complaint. We want to identify the phrase because of which the model is saying that this is complaint. Okay, it is an explainable model. It will give you an explanation also that yes, the model is saying this is a complaint because of the presence of this particular phrase. So this is like here, the packaging of the product is great, but the taste is pathetic. So this packaging and the great and the taste pathetic, these are the important words, and because of the presence of these words, you know, it is saying that this is a complaint. And also packaging is a aspect and taste is a aspect. So it is complaining about the taste but not about the packaging. So we are doing the aspect based complaint analysis. So these are the domains: book, edible, electronics and fashion. For book, these are the aspects: content, packaging, price, quality. For edible, these are the aspects. For electronics, fashion. So yeah, you can see these are the sample instances. And finally, we also developed a deep learning based. It is a two-stage process. In the first stage, we identify the aspect categories. In the second stage, for each aspect, we are identifying whether it is complaint or the non-complaint. So it is a two-stage. First stage, you identify the aspects which are mentioned in the complaint. In the second stage, you identify whether there is a complaint or non-complaint. Yeah, and now we are also working on the multimodal aspect, like the review can also contain the image. So you have to identify the aspect category, their label, and also the part of the context which is of this explanation, because of which it is of complaining nature. So like receipt on package, so this is the explanation. So this is also will be the output. So we this is called the, you know, that we developed a you know, that this is the data set, like we have the aspect categories, complaint, non-complaint labels and the span. And this is our model. So we have a visual aware encoder, and also in order to, you know, because the reviews are very short, so from the reviews it is very difficult to understand the context. So we are also adding the common sense knowledge. So there is a common sense database, a ConceptNet. So we have, through ConceptNet we are adding some common sense knowledge. and that way we are, you know, enhancing the context of the reviews. Yeah, so apart from this, as I mentioned also in the first step, we are also working on this code mix meme. Not only intervention I discussed, but before that we also worked on the classification, like, and that too in the code mix. Like in the Indian setup, we are mostly writing the code mix memes, no? Like our memes are containing the code mix text. So basically, you know, these are some of the examples of our code mix memes. So collected such data set where code mix memes are there, and also there are some cyberbullying like hateful memes. So you know that we collected this data set, we annotated them into bullying and non-bullying, and also with their emotion. Sometimes, you know, directly from the meme you will not be able to understand whether this is hateful or non-hateful, because there is sarcasm present. Maybe there is an implicit hate. So that's why sarcasm is also important. So we categorize this into sarcasm, bully, harmfulness, and the sentiment. So you know that we proposed a clip based model, okay, and where it is again a multitask based model, where our main task is the bully detection, but the sentiment, emotion, and sarcasm detection are our auxiliary task. Because I mentioned that sometimes there is an implicit bully or the implicit hate. So you know that sarcasm detection is also helpful. Yeah. So these I already mentioned. Okay, so these are some of the, you know, works where we are doing, and we are also, you know, applying the multimodality, because as I mentioned that multimodality is very, very useful, and nowadays NLP research is mostly on multimodal processing. So we are working on how to combine the image, text, audio and the video data all together to get a better classification accuracy or, you know, generation accuracy.